All right, let's jump right in. We are about to explore what happens when you smash together two of the most powerful and, let's be honest, kind of mind-bending technologies ever created: quantum computing and artificial intelligence. And this isn't just about giving AI a speed boost. Nope, this is about completely rewriting the rule book for how computation even works. And this quote right here, it just nails it. The source material calls this a fundamental shift in the ontology of data representation. Okay, that's a mouthful, but what it's really saying is profound. We're not just building a faster car, we're inventing an entirely new kind of physics to power it. This changes the very nature of information itself.
And this table really shows you the nuts and bolts of that difference. You know, our phones, our laptops, they all use bits. Think of them like light switches. They're either on or off, 1 or 0. Simple. But quantum computers, they use qubits. And a qubit is more like a dimmer switch. It can be on, off, or anywhere in between, all at the same time. That's superposition. And the connections? Totally different. Instead of simple logic, they use entanglement, this strange, almost magical link between qubits that lets them process just unimaginable amounts of information at once in what's called a high-dimensional Hilbert space. Don't worry about the term, just picture a vastly richer, more complex playground for computation.
So here's our game plan for today. First, we're going to talk about why this is a whole new computational era. Then, we'll get into the weeds of entanglement, the real magic behind all this. After that, we'll look at the partnership between quantum and AI, check out some mind-blowing real-world examples, and finally, take a peek at the road ahead. And make no mistake, this isn't science fiction anymore. We are right at the dawn of a new age, where the weird, wild rules of quantum mechanics are set to become the engine for the next wave of intelligence. So at the heart of all this is one single concept. It's a phenomenon that drove Einstein crazy. He called it spooky action at the distance. So what in the world is quantum entanglement? This, right here, is the secret sauce. Entanglement is the fundamental property that makes this whole quantum AI thing not just possible, but absolutely revolutionary. Okay, so in the simplest terms, it's when two or more particles get linked up. Their fates become intertwined. So if you measure one, you instantly know the state of the other. And the crazy part? It doesn't matter how far apart they are, across the room or across the galaxy. The connection is instant. Here's a pretty cool way to think about it. Imagine you've got two magic coins. You keep one, and you give the other to your friend who zips off to the other side of the universe. The second you flip your coin and see it landed on heads, you know without a shadow of a doubt that theirs landed on tails, instantly. That's entanglement, a deep, unbreakable, faster-than-light connection. So, the big question, what does this have to do with AI? Well, think about it. That instant correlation creates these incredibly powerful built-in relationships between qubits. It's kind of like having a super dense neural network that comes pre-wired, letting the AIs see these deep, complex patterns in data that would be completely invisible to even our best supercomputers today. Now let's dig into how this partnership actually works, because it's not a one-way street. It's not just quantum making AI better. It's this amazing symbiotic relationship where each technology pushes the other one forward. First, let's look at what quantum brings to the table for AI. We're talking about massive, almost unbelievable speed-ups for optimization problems, the kind of stuff that would take a normal computer centuries to even begin to solve. In reinforcement learning, it lets an AI agent explore way more strategies, way more efficiently. And it can simulate multiple possible futures at the same time, which, as you can imagine, leads to much smarter decisions. But here's what I think is so cool. It goes the other way too. AI is actually helping us tame quantum computers. See, these machines are super delicate. They're sensitive to the tiniest vibrations, the smallest temperature change, what physicists call noise. So researchers are building quantum agents. These are AIs that act like an intelligent co-pilot for the quantum computer, managing experiments, designing circuits, and constantly correcting for those errors to keep the whole thing running smoothly. Okay, that's enough theory. Let's talk about where the rubber meets the road. This stuff is already moving out of the physics lab and into the real world, starting to solve some of our biggest, toughest challenges. And drug discovery is just a perfect example. A quantum computer can simulate a molecule with near-perfect accuracy, something classical computers just can't do. This means we can model exactly how a new drug will bind to a protein in the body, understand its behavior at the most fundamental level, and even predict side effects by simulating what's called reverse docking. All of this happens before a single physical experiment is run.
This could literally slash the time it takes to develop new life-saving medicines.
And the value here is just staggering. Estimates suggest that by 2035, quantum computing could create up to $500 billion in value. And that's just in the life sciences industry alone.
And it goes way beyond medicine. In cybersecurity, quantum machine learning models are already hitting over 90% accuracy in detecting complex network threats. And in physics, Google used a quantum algorithm to simulate how information scrambles inside a quantum system, a process so incredibly complex that it's literally impossible for any classical computer on Earth to model. And when I say impossible, I'm really not exaggerating. For that specific task, Google's quantum processor was 13,000 times faster than Frontier, the world's #1 supercomputer. A calculation that would have taken Frontier years was done in a matter of hours. That's not an improvement. That's a paradigm shift.
So, where do we go from here? The path is getting clearer every day, but, there are still some pretty significant mountains to climb.
This is basically the industry's roadmap. Right now, we're in what's called the NISQ era. That stands for Noisy Intermediate Scale Quantum. It's all about learning to work with these small, error-prone machines. Over the next 5 to 10 years, we're expecting to see small but properly error-corrected computers with over 1,000 qubits. And then, 10 to 20 years out, that's when we hit the big leagues with large, fault-tolerant machines that can unlock those massive breakthroughs.
And you know who's noticing? The investors. As they say, follow the money. And wow, is the money pouring in. Private equity funding is on track to nearly triple from 2024 to 2025, and that's not even counting the billions in government funding. This huge surge of cash tells you everything you need to know. This is moving from a purely academic pursuit to a real commercial industry.
But you know what? The biggest roadblock might not be the hardware or the physics, it's the people. There is a massive talent shortage, especially for specialists who understand things like quantum error correction. We can have all the funding and all the roadmaps in the world, but without the brilliant minds to actually build and program these machines, progress is going to hit a wall. That talent gap is maybe the biggest challenge we face.
So, here's the bottom line. The quantum AI revolution isn't some far-off dream anymore. It's here. It's happening right now. The fusion of these two incredible fields is going to unlock discoveries and create technologies that we can barely even wrap our heads around today. And that leaves us with one really big question. Are we ready to redefine what intelligence itself even means?